For centuries, humans looked up at the night sky with wonder and curiosity. The stars, planets, and celestial tapestry above sparked countless myths and stories. Our ancestors sought to understand the mysteries of the cosmos, but their tools were limited. Before the telescope, observations were made with the naked eye. Ancient astronomers tracked the movements of celestial objects, charting their paths across the heavens. The idea of magnifying distant objects, however, began to emerge. There is evidence that lenses were used for magnification as far back as ancient Egypt and Mesopotamia. In the 13th century, eyeglasses were invented in Italy, demonstrating the practical applications of lenses. These early lenses paved the way for the eventual invention of the telescope. Hans Lippershey, a Dutch spectacle maker, is often credited with the invention. In 1608, he applied for a patent for a device that could magnify distant objects. Galileo Galilei, born in Pisa, Italy in 1564, was a mathematician, physicist, and astronomer who would forever change our understanding of the universe. From a young age, Galileo displayed a keen intellect and a thirst for knowledge. He studied at the University of Pisa, where he initially pursued medicine before turning his attention to mathematics and physics. In 1609, Galileo learned of the invention of the telescope in the Netherlands. Intrigued by its potential, he immediately set about building his own. His skills as a craftsman and his understanding of optics allowed him to create telescopes that far surpassed the capabilities of those that came before. Galileo's telescopes were not the first, but they were by far the most powerful and sophisticated of his time. Through careful experimentation and a deep understanding of optics, he was able to achieve magnifications that were previously thought impossible. While the telescopes of his day suffered from blurry images and limited magnification, Galileo's instruments were remarkably clear and powerful. He experimented with different lens shapes and arrangements, meticulously grinding and polishing his own lenses to achieve optimal performance. He also increased the length of his telescopes, which further enhanced their magnifying power. Galileo's most powerful telescope, with a magnification of about 30 times, allowed him to make groundbreaking discoveries. What he observed would forever change our understanding of the universe and our place within it. In 1610, Galileo made a series of astounding discoveries that would challenge the prevailing view of the cosmos. His observations of Jupiter, the largest planet in our solar system, revealed 4 faint points of light that appeared to be orbiting the gas giant. He carefully tracked their movements over several nights, observing that they changed position relative to Jupiter. He concluded that these points of light were not stars, but moons in orbit around Jupiter. He named them the Medicean stars in honor of his patron, Cosimo II de' Medici, the Grand Duke of Tuscany. This discovery of Jupiter's moons, now known as the Galilean moons, was a profound challenge to the prevailing geocentric model of the universe. Galileo's observations provided the first clear evidence that not everything in the universe orbited the Earth. The existence of celestial bodies orbiting another planet directly contradicted the geocentric model. Galileo's observations of Jupiter's moons provided compelling evidence for the heliocentric model proposed by Nicholas Copernicus. Galileo's discoveries did not end with Jupiter's moons. He also turned his telescope towards Venus, the brightest object in the night sky after the moon. He observed that Venus, like our moon, exhibited phases, waxing and waning in a predictable cycle. These phases of Venus were inexplicable under the Ptolemaic geocentric model. If Venus orbited the Earth, it would always appear as a crescent or a new phase. The full range of phases observed by Galileo could only be explained if Venus orbited the Sun. When Venus was on the opposite side of the Sun from Earth, it appeared full. Galileo's observations of Venus's phases dealt another blow to the geocentric model. His discoveries provided further support for the heliocentric view of the solar system. Galileo's discoveries, while groundbreaking, ignited a firestorm of controversy. His support for the heliocentric model, which contradicted the teachings of the Catholic Church, was seen as heresy. The Church, deeply invested in the Ptolemaic system, viewed Galileo's ideas as a threat to its authority. In 1616, the Church condemned the heliocentric theory as false and contrary to Scripture. Galileo was ordered to abandon his support for Copernicanism and forbidden from teaching or defending the heliocentric model. Despite these warnings, Galileo continued his astronomical observations and published his findings in his book, Dialogue Concerning the Two Chief World Systems, in 1632. This book presented a compelling argument for the heliocentric model, infuriating church officials. In 1633, he was found vehemently suspect of heresy and forced to recant his views. Despite the persecution he faced, Galileo's scientific contributions extended far beyond his astronomical observations. He was a pioneer in the field of experimental physics, conducting groundbreaking experiments on motion, gravity, and inertia. His work laid the foundation for Isaac Newton's laws of motion and universal gravitation. Galileo's emphasis on observation, experimentation, and mathematical analysis transformed the scientific method. He argued that the universe should be understood through direct observation and empirical evidence. His approach to science helped usher in the scientific revolution, a period of unprecedented scientific discovery. Although Galileo's discoveries initially met with resistance, his work eventually gained widespread acceptance within the scientific community. His observations of the heavens helped to shift the paradigm from an Earth-centered to a Sun-centered view of the solar system. Galileo's telescope opened a new window into the cosmos, revealing a universe far more vast and complex than previously imagined. His observations of Jupiter's moons and the phases of Venus provided the first compelling evidence for the heliocentric model. His work inspired generations of astronomers to explore the heavens with ever more powerful telescopes. In the centuries that followed Galileo's pioneering observations, astronomers continued to push the boundaries of our understanding of the universe. Isaac Newton's laws of motion and universal gravitation provided a mathematical framework for understanding the motions of celestial objects. William Herschel's discovery of Uranus in 1781 expanded the known boundaries of our solar system. And in the 20th century, Edwin Hubble's observations of distant galaxies revealed that the universe is expanding. Galileo's legacy lives on in these incredible achievements, a testament to the power of human curiosity. Galileo's telescope not only revolutionized our understanding of the universe, but also forced us to reconsider our place within it. The Earth, once considered the center of creation, was relegated to the status of a mere planet orbiting an unremarkable star. This realization was both humbling and awe-inspiring. As we continue to explore the universe, we are struck by its immensity and our own relative insignificance. Yet, within this vast cosmic arena, life emerged on our small planet, evolving over billions of years. This remarkable journey of discovery, ignited by Galileo's telescope, continues to inspire us to reach for the stars. The challenges we face as a species pale in comparison to the vastness of the universe. We are, after all, children of the stars, our very atoms forged in the fiery hearts of distant suns. Galileo Galilei's invention of the telescope marked a turning point in human history. It was a technological leap that shattered our Earth-centric view of the universe and ushered in an era of unprecedented scientific discovery. His observations of Jupiter's moons, the phases of Venus, and other celestial wonders challenged long-held beliefs. Though he faced persecution for his ideas, Galileo's legacy has endured for centuries. His pioneering work in astronomy, physics, and the scientific method continues to inspire generations of scientists and stargazers alike. As we look up at the night sky, we are reminded of the profound impact that a single individual can have on the course of human history.